Today we're going to look at a very basic concept in chemistry. It's the basis for all the math we're going to be doing. And this is the concept of the mole. The mole is a unit of measurement. If you remember from your textbook, it is one of the 7 SI units. A mole is the amount of a substance. And it is a constant amount by definition. You know, it's very similar to the concept of a dozen. If you have a dozen, you have 12. It doesn't matter if you have 12 pencils, 12 eggs, or 12 elephants. There are 12 of them in a dozen. It's a unit of counting. Do they all weigh the same? Of course not. Why not? Well, that's because elephants weigh more than eggs. So if you had 12 of them, of course 12 elephants would weigh more than 12 eggs. A mole is a certain number of particles. Is it 12? No. Is it 2? No. It has to be some huge number because what chemists are measuring are atoms or molecules, something that's very, very small. And so we measure by using Avogadro's number. That's how we count. There is a certain number of particles in this bundle, this unit called the mole. And the number of particles were determined by a scientist whose name was Avogadro. He determined that the number of particles in 1 mole of any substance would be 6.02 times 10 to the 23rd power. That's to 3 significant figures. Now, the mole has a second definition because if you have that many particles, they do have mass associated with them. The mass at this point is something big enough to hold in your hand, to put on a scale and weigh. And so the mass here, the molar mass, is in units of grams. Grams per mole. So, if we wanted to look at a periodic table, we could determine the molar mass for different particles. If we wanted to look at aluminum, we would say that the molar mass for aluminum, and I'm just looking at a periodic table now, the molar mass for aluminum would be 26.981538 grams per mole. Now, your teacher will give you instructions for how she or he wants you to round off that number. I don't think I'm going to ask you to carry it out to, gosh, how many sig figs is that? 7 or 8? So in my class, I would ask you to round off either to a whole number or to the 10th place. If you're using WebAssign, 10th place or maybe 100th place will be helpful for you to get the correct answer. But for here, I'm just going to, on the board, for simplicity, round off to the nearest whole number. So I would say that aluminum is going to be 27 grams per mole. That would be the units, that would be the mass of 1 mole of aluminum. What if you were looking at something like O2? Oxygen is a diatom. And so O is on the periodic table, rounded off to the nearest whole number, that would be 16. But O2, there are 2 of them. So this would be 32 grams per mole. MOL, believe it or not, is the abbreviation for MOLE. And then water. For water, we have molecules of water. How would we get this value, the mass of a mole of water? Well, you've got to look at the formula, H2O. And if the formula is H2O, I'm going to have to add 2 hydrogens and 1 oxygen to get the total molecule's mass. Well, oxygen is 16. If you look for hydrogen, 1 hydrogen atom is 1, but 2 then would be 2 grams per mole for a total of 18. This would be 18 grams per mole. And then calcium hydroxide. Calcium hydroxide is going to be a little bit harder. And there's different ways that you could do it. Looking at calcium, we see that its mass is going to be 40. Now, I could then look and say, well, I have 2 oxygens. Oxygen is 16. 16 and 16 is 32. And then I have 2 hydrogens. 2. So this would tell me 74 grams per mole. The other way you could do this would be 40 for the calcium. Then you could say that an oxygen and a hydrogen would be 16 plus 1, that's 17. And 17 times 2 would be 34. Either way you want to do it, you're going to get a total of 74 grams per mole as the molar mass. Now, you'll notice over on the side of the board here, I put together a very quick flow chart. This flow chart focuses on the central topic of the mole. And for our definitions, we see that 1 mole can be either a certain number of particles, Avogadro's number, 6.02 times 10 to the 23rd, or it could be something else. I didn't write this number in pen because this number changes. This number has to be determined or calculated by using the periodic table. So rather than being able to write down a number, which is a constant, I need to write down that this is going to be determined from your periodic table. See your periodic table to get this value. Okay, let's work just 1 or 2 quick problems. I'm going to pull this over to the side, and let's look at our first problem. If I have 2.75 moles of sodium chloride, how many grams of sodium chloride do I have? Now, my students are going to be doing this a very exact way because I want them to use dimensional analysis or to factor label as they work problems. So, we would start with the number that we are given. That would be 2.75 moles of NaCl. I'm going to look at my road map. The road map says, I'm here at moles. Where do I want to go? Well, I'm being asked to find grams. And grams is here under mass. So if I want to go from moles to grams, that's going to be a 1-step problem. So I'm going to set this up as a 1-step problem. Now, do I want to be in moles? I do not. I want to be in grams. I want moles to disappear, to go away. So I'm going to get rid of moles of sodium chloride by putting it on the bottom. This is the important part. Dimensional analysis or factor labeling works because your units can cancel. The flow chart shows me that it's always 1 mole. And if I want to go from moles to mass, I go through the periodic table. Very quickly, then I would think sodium is 23 and chlorine is 35. Actually, I'm going to use 35.5 for a total of 58.5 grams of NaCl. It's 1 mole of NaCl. So, now I can see that if I would simply take 2.75, multiply it by 58.5 grams in 1 mole, then that will tell me the total mass of 2.75 moles of NaCl. I would show 3 significant figures in my answer. Let's look at this next problem, which says if I have 2.75 moles of NaCl, How many particles, how many empirical units would I have? So I'm starting off with the same number, 2.75 moles of NaCl. Look at where I'm starting again on my flow chart here. I have this many moles of sodium chloride, but this time I want to go here to the number of particles. Moving from moles to particles is a one-step problem. Therefore, I need a one-step block. It's always 1 mole of NaCl. The 1 is typed on the board. It's not going to change. So it's always 1 mole, so my units here are going to cancel out. Now, if I want to go to particles, what do I use? The actual number is there because it does not change. It is 6.02 times 10 to the 23rd particles. So, if I take 2.75 and multiply it by 6.02 times 10 to the 23rd particles, that's going to tell me how many particles of sodium chloride I have in 2.75 moles of sodium chloride. Do the math. Let's look at 2 more problems real quickly. Okay, now for this one, I have 2.50 times 10 to the 23rd particles. So I'm going to start with that number, 2.50 e to the 23rd. Do you remember the flow chart? I'm going to be moving from particles to moles. It's always 1 mole, and 1 mole always contains 6.02 times 10 to the 23rd particles of NaCl. It helps to keep up with your units as the year goes on. Things get more complicated. This is 1 mole of NaCl. So in this case, I would take my starting number of 2.50 times 10 to the 23rd, and I would be dividing it by 6.02. I know you're thinking, I can do this in a simpler fashion. I know all you want to do is multiply or divide to get these answers. But I'm telling you that in my class, if you do not show this format, then you will get no credit. I'm not interested in the answer. I'm interested in the process of how you're going to solve this type of problem. Learning how to use factor labeling or dimensional analysis will prove quite useful as the year goes on. So we need to modify the way we think and how we work problems. How about this one? Here we're given so many grams of NaCl, we want to find moles. Start off with the number that you're given. So many grams of NaCl. And I'm going to flip the board back over to go from mass, grams, to moles. We must again use the periodic table. So, I'm going to use the number on the periodic table, which we calculated previously. 58.5 grams of NaCl is 1 mole of NaCl. Dimensional analysis, factor labeling, is a way of keeping up with your units to get you to the unit you want. Here we're going to take 75.5 grams and we're going to divide it by 58.5 grams to determine the actual number of moles of sodium chloride that we have. And when we do this, your teacher will tell you how she wants you to use significant figures. I'm going to use 3 significant figures in my answer here, and here, and here, and here. I hope you might agree. Work these problems and set up a few more. There should be examples either on worksheets or in the back of your textbook to help you move along.